Good morning, everyone. I'm Zemi and I'm the environment engineer in our group. Today I'm here to present the result of the energy system that aims to make the project become more sustainable. Our design team decided to use the combined energy system, including the solar PV system and combined heat and power system and the grid to generate the energy that can supply the building. You can see the solar panel system is a technology that to make use of the renewable and green source solar energy to create electricity. Roof-mounted PV system will be used here, and most of the panels are installed on the top roof of the tower. According to the energy demand assumptions and the estimation of the available area for the panels, we can see the system size is about 70 kilowatts DC. In order to determine the best option to be used in Melbourne, we use the system advisor sample to model to use to figure out it. By changing the solid elements like the space, tilt angle, orientation, and quantities. Based on the literature review and the model simulations, we can see the north-faced panels with tilt angle of 30 degrees will be suitable to be used in Melbourne. The space will influence the shadings, and consequently it will have an impact on the output efficiency. We can see if I set the space to be 2 meters, which is equal to the width of the solar panels, there is a 30% shading in width, which would reduce the energy output efficiency. But if I make it big, make the space to be 2.5 meters, we can see the shading become less, and of course the output will increase. The combined heat and power system will generate most of the energy and heat. Of course, we can see a good energy design not only to just meet the energy demand. It also needs to be cost effective. We can see the levelized cost of electricity for the solar panel is just $0.088 for the solar panels, and that is just half of that for the CHP systems. The NPV can apparently show the difference, show the different values when the combined system with different size. We can see when the CHP system with 110 kilowatts system size, the NPV value will be the lowest, which means it's the most cost-effective option. Last but not least, through the two figures, we can see the greenhouse gas emission generated by the solar PV will be the least, and which can be ignored. And we can see here the CHP system will be generate about 500 megawatt hours when use the CHP to generate the energy. But grid electricity usually use the coal, and the coal maybe had about 900 greenhouse emissions. So through calculations and assumptions, we can see our project can make about 15% greenhouse emission reduction, which didn't satisfy the targets. Based on the calculations and the cost analysis and greenhouse gas emission analysis, we can see the best option is the solar panel combined system with solar panels, CHP system, and grid. The combined the combined heat and power system should be 110 kilowatts, and the solar panel is just about 67.2 kilowatts, and which the solar panel just generates 6% of the electricity which didn't satisfy the target. But there is over 70% electricity will be generated on site, which is good. Okay, that's all.